Okay, so for this video, we will be expanding on the use of z-scores and how we can apply them to different situations. So if you'll recall in the last example, we calculated a z-score, and we'll get into what the exact formula for that is in a minute. But so we calculated a z-score, and that told us what percent of data was either the z-score always tells us to the left, and from that we can figure out how much is to the right, because we're always working with 100%. So now we're asked to figure out what z-score results in 10% of the data being to the left. Now this is sort of like an out of context question. This is sort of thing they ask in your textbook. So it's not necessarily helpful to know like what z-score has 10%, just like to know it. However, we're going to tie this to a context in a second, and sometimes we might want to know like what mark has like 10% below or 10% above, or like, you know, what data point results in like having a certain percentage. Like that could be valuable to us. I think sometimes in your textbook they'll talk about like people who make decisions about warranties, like how long warranties should be, because the idea being that when a company puts a warranty on their product, they don't actually want to have to fix a whole lot of things. So usually, if you know something has a 2-year warranty, it probably won't break during those 2 years. It'll probably break like after that, like after 3 years or something like that. And so companies would genuinely like collect data and make decisions based off of that. So sort of finding a compromise between like what sounds good to a consumer. So like a 2-year warranty probably sounds good, but they might know from their data that like they'll only have to repair, you know, 5% of their of whatever their product is, for example. Anyway, but we're going to start here. So we want to know what z-score has 10% of data to the left. So we're still going to use the z-score table, but we're kind of going backwards. So let's take a look at that. So one important thing to note is that the mean would have a z-score of 0, right? Because the mean is the center, and the z-score is still telling us sort of how much of a standard deviation is a certain value away from the mean. So if we're right on the mean, it's at 0. And so again, when something is normally distributed, it means that the mean is halfway. So 50% should be less than the mean, 50% should be more than the mean. So if we are looking for 10% below, we're actually sort of in the wrong spot. So as we can see, that 0 right up here in the corner has that with 50%. So if we're looking for 10%, that would not be up here. These numbers are bigger than that, so we need to go to the negative side. So here we are on the negative side of things. And so remember, these numbers are in decimal form. We were asked a question in percent form, so 10% as a decimal is 0.1. So what we're going to do here is we're going to try to find the number that is closest to 0.1. Now, it might not be dead on. Sometimes z-scores aren't like perfectly perfect. So if we're down here, actually, yeah. So the closest ones, and we're trying to get closest. So negative 1.29 is 0.0985, and negative 1.28 is 0.1003. So this would be the closest to 0.1. It's only 3/10,000ths off. So it's very close. So that is the z-score that we're going to use, negative 2.8. So to the left, we have negative 2.8 equals the z-score to the left. Now to the right, again, we can look it up on the thing, and I think I actually will just look it up. just to practice showing you like how to find things on the thing. But it should be the opposite. It should be positive 1.28. So let's check. Yeah, so if we have 10% of the data to the right, that means there should be 90% of the data to the left. So if we're down here, now we're in the positive, so we got 1.2, go all the way over here to 1.28, we get 0.8997, and then on the other side we have 0.9015. So even though this one has the 90 on it, it's the 0.8997 that is closest to being 0.9. So as I mentioned, it's just the positive 1.28, which makes sense because remember our bell curve is symmetrical. Okay, so now we're going to try to tie this to a context. So we're going to have a provincial exam that has a mean mark of 74%. Now let's say that to get a certain award, you need to beat 90% of the people who write the test. So you need to be in the top 10% of the people who write the test. So top 10% would mean that we need a Z-score of 1.28. So that's what we were just looking at. 10% of data to the left would mean that you're like you've hit the sort of the lower 10%. 10% of the data to the right means that's the edge of the top 10%. So the Z-score we need is 1.28, and we know that the average or the mean mark is 74. So we need to pull together what we used last time into a formula and then solve. Okay, so this is our formula where x is the value that is the single value. So in this case, it's the mark that we want on a provincial exam. Mu, again, represents the mean. Sigma is the standard deviation, and Z is our Z-score. So we know a lot of this information. We also know that the standard deviation on this test is 5.4. Sorry, I forgot to mention that earlier. And now, so first thing we're going to do is we're going to plug in the values. So our Z value is 1.28, so we put 1.28 over here. We don't know. We're trying to figure out how much we need to get on this test, so we'll just leave that as X. Our mean is 74. And again, our sigma is 5.4. Now, to solve this, remember we want to work backwards. This is also something we could use a flowchart for if you're familiar with that. So, I don't have a lot of room, so I'm going to do without a flowchart. If you guys want, I can show you how to do it in a flowchart, though, because we used to do those a lot, and you guys tended to be pretty good at them. So, we're dividing by 5.4, so we need to multiply by 5.4. That cancels these guys out. Okay. So then we're left with x minus 74 is equal to 6.912, which again we could just get from multiplying. So since we've got x minus 74, we need to do the opposite. We need to add 74. I'm going to run out of room, so over here I'm going to wind up with x equals 80.912. So if we rounded that, you would need to get 81% on the exam in order to score in the top 10% of people who write the exam. So that's just another way we apply Z-scores. It's sort of like working backwards. I know that this is new. I know that we haven't really done it together in class. So if you would like more examples on how to use Z-scores, just let me know.